Hello everyone, this is Vijayasri working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discuss about sorting techniques in C, in that bubble sort. Overview of the session, bubble sort, definition, working principle of that sorting technique, then time complexity, pros and cons. Then, what is a sorting? Sorting means arranging the elements in a particular order, either ascending or a descending. So, bubble sort is a simple comparison. Bubble sort is a simple comparison-based sorting algorithm. It repeatedly steps through the list, compares the adjacent items. If they are in wrong order, swaps them. Then, working principle, the algorithm bubbles the largest unsorted element to its correct position in each pass. In each pass, from the unsorted elements, it will get sorted to its correct position. This process is repeated for all the elements until the list is sorted. It will get repeated till the elements of the list are get sorted. Time complexity, best case is order of n, and worst and average cases of this sorting technique is order of n square due to nested loop. In this case, we have to use a nested loop. Then space complexity of this is order of 1. Then pros. It is simple to understand and implement. Works well on small data sets. It works well on small data sets or nearly sorted data. Then cons. Inefficient for larger data set due to its time complexity. Because the time complexity of this is order of n square. Not suitable for performance critical applications. It is not suitable for critical applications. Then how it works. Start at the beginning of the list. Compares first two elements. We'll compare because the two adjacent elements are to be compared here. Compare first two elements. If the first is greater than the second, swap them. If they are in wrong order, then we have to swap the elements. Move to the next pair. We have to go with the next adjacent elements and repeat the same comparison. If needed, we have to swap them. Continue this process until end of the list. Repeat the entire process for each element in the list until no more swaps are needed. We have to repeat this until there are no swaps. That means all the elements are its correct positions. For example, consider a array. For example, consider an array A. Here I am taking size of the array is 5 and the values here I provided as 6, 5, 4, 3, 2. Then the index of this array is 0, 1, 2, 3 and 4 always. End of the array is n minus 1. Index position is n minus 1. Index starts with 0. Then, so what is the first step? Starts at the beginning of the list. Compare the first two elements. If the first is greater than the second, swap them. So, start. So, here we are starting. What we are doing? We are comparing with that adjacent element. So, we are comparing C with 5. C with 5. If C is greater than that, we have to swap them. So, now it is 5, 6, 4, 3, 2. Because they are in wrong position. 6 is greater than the 5. So, again, this process has to be repeated until no swaps are needed. The next two adjacent elements are 6 and 4. They are in wrong order, so we have to swap them. Now, after swapping, 5, 4, 6, 3, 2. Now, the array is this. So, after this index, we have these two. So, we have to compare these two elements, that is 6 with 3. 6 is greater. So, we have to swap them because they are in wrong order. After swapping the elements, the array is 5, 4, 3, 6, 2. Now the next two are these two. So after swapping, because they are in wrong order, so we have to swap them. Because the principle of bubble sort is that only. 5, 4. In place of 6, we'll have 2, 6. Now, the largest element in the list are at its correct position. Now, 6 reached end of the array. Now, it is a correct position. This, I am considering this as the pass 1. So, after pass 1, the array is now 5, 4, 3, 2 and 6. But this is not a sorted array. So again we'll start with the first element. We'll compare the next element, the next adjacent element, that is 5 and 4. They are in wrong order, so we have to swap them. Now it is 5, 4, 3, 2, 6. Now the array is this. Again we have to compare these two adjacent elements. Now it is, we have to compare this. Again it starts with the first element. Now we have to compare 5 with 4. They are in wrong order. So after swapping it is 4, 5, 3, 2, 6. Now we have to compare 5 with 3. They are in wrong order. So after swapping it is 4, 3, 5, 2, 6. Again we have to compare these two. They are also not in a correct position. So we have to swap them. 2, 5, 6. So we'll compare these two. Do swapping needed? No. When we are swapping, when this element is greater than the next element. So here no swapping is needed. So I'm considering the array is, now the array is this. So this I am considering as the pass 2. Now after pass 2, the array is 4, 3, 2, 5, 6. So after 2 passes, the large 2 elements are at its right position. Now again we start with the first element. We'll repeat this process until no swaps are needed. So we'll compare these two. They are not in a correct position. So swapping is needed. So it is 3, 4, 2, 5, 6. Again we'll compare these two. They are not in correct position. So 3, swapping is needed. 4, 5 and 6. Now we'll compare these two. Do swapping needed? No. Now we'll compare these two. Do swapping needed? No. Now the array is this. After this, I'm considering as the pass 3. After pass 3, the 3 elements are at its correct position. Now the array is 3, 2, 4, 5, 6. Now again we start with the first element. We'll compare with the adjacent element, that is 3 and 2 are to be compared. So now they are in wrong. So swapping needed. So it is 2, 3, 4, 5, 6. Again we'll compare these two. Do swapping needed? No. We'll compare these two. No need of swapping. Now we got the sorted array. So this I am considering as the pass 4. Here number of elements are 5. After pass 4, the 4 elements of the array at its correct position. That means automatically the remaining element will be at its position, at its correct position only. So here the number of passes needed are 4. Number of elements are 5. So how many passes we need? N minus 1. And in the pass, what I am doing? I am checking checking the next 2 adjacent elements. That means I am checking, suppose it is I with I plus 1. I plus 1. This is also repeated until the largest element is its correct position in that particular pass. So here we need 2 loops. One is for the passes and another is for the comparisons. This comparison, whatever we are comparing the adjacent element, that has to be nested in that loop. These 2 loops are in nested form. And after that, in that comparison, what I am doing? I am checking the I with the I plus 1. If I is greater than I plus 1, then we have to swap. Swapping logic already we know. So, we'll go with the program. So, here I consider A of 30. This array can store 30 elements. Then I under J, because we have to use our nested loop. We needed 2 loops here. One loop is for passes and one is for comparisons. And if they are in wrong order, that means if A of, let us suppose this is I and this is J. If A of J is greater than A of J plus 1, because suppose here I am checking these 2, 0, 1, 11, 12 and 11. We are comparing these 2. This is J. Now next J plus 1, because it is 0 and 1. So if A of J is greater than A of J plus 1, then we have to swap using a swapping logic. The number of elements here is 5. Using a scanf function, we can store the values. These are the values. Then this is the loop for the passes, and here this is for the comparisons. And now here I consider the values of the array are 4, 3, 1, 2, 5, 2. Then this is A, 0, 1, 2, 3, 4, 5. Now I equal to 0, I less than 5, condition is true. 0 less than 5, condition is true. So the control enters into the nested loop. J is 0. J minus N minus I minus 1. Here I consider this because we are comparing here unnecessary comparisons. Like after this, no need to compare 3 to 4. These are the unnecessary comparisons. For that, to not doing that unnecessary comparisons, here I consider a condition as J less than N minus I minus 1. So if A of J, that is A of J is A of 0. A of 0 greater than A of J plus 1. That means 0 plus 1. Now it is 1. A of 0, I am comparing with A of 1. Are they in correct order? No. So, then swapping has to be take place. So, now it is 3, 4, 1, 2, 5, 2. After swapping, again J plus plus. Now J becomes 1. This will be compared with the next element. Then the swapping has to be take place. We'll repeat these steps until no swapping is needed. So, this is about bubble sort. The next session will discuss about the remaining sorting and searching techniques. Thank you.